All right, now we're going to be looking at page 2. So number 7 wants us to describe the transformations that have occurred when we have this minus 5 in the absolute value bars. That's going to move our graph left or right, opposite of our intuition. So a minus 5 is going to move it right 5. And the minus 1 outside is going to shift our graph down 1. 8, we want to write an equation. So we've got f of x. We want our absolute value graph to reflect across the x-axis, which will be a negative out front, vertically stretch by a factor of 1/2, so it'll be a 1/2 also in front of my absolute value bars. Right 3 units, so to go right, we're going to do x minus 3 inside the bars, and up would be a plus 4 outside my bars. So we'll have f of x equals negative 1/2 absolute value of x minus 3 plus 4. On 9, we want to graph this function on the grid below. So we've got f of x equals negative 2x plus 3 plus 1. We want to be able to move my vertex. This plus 3 is going to go left 3. The plus 1 is going to go up 1. So that's where my vertex is going to go. So my vertex is going left 3, up 1 unit, which is where my vertex will be. The negative 2 is my vertical stretch, and it's a reflection. If we use the vertical stretch using that negative with my slope, it's going to do the reflection for me. So negative 2, we can rewrite it as negative 2 over 1. So we're going to go down 2 and then over 1 unit. So from my vertex, we go down 2 over 1, and we're going to go over 1 in both directions. Down 2 over 1, down 2 over 1, and that'll give me the coordinates that I need, or the points that I need in order to draw my graph correctly. Okay, so then on to this next one. Here it gives me f of x, it gives me the graph of f of x, and I need to graph these transformations over to the right. So A, we've got f of x plus 2. That plus 2 will go up 2. So that means every single point on this graph goes up 2 units. So my left point is going to go up 2 units, and there will be my new spot. Get a bigger pen here. My bottom point is going to go up 2 units, and that'll be my new spot right there. This next point, go up 2. There's my new point. And the last one will also go up 2, giving me my new point. So then when I connect them, that'll give me my graph of f of x plus 2. So now if we do f of x minus 3, that's going to be moving our graph right 3, because we always want to go in the opposite direction. So all of these points that we have are going to go right 3 units. So back to the original, we go right 1, 2, 3 units. Bottom point goes right. Oops, that was left. Just kidding. We're going to go right 3 units. 1, 2, 3 units. Bottom point will go right 3. 1, 2, 3. Middle point to the right. 1, 2, 3. And top point to the right. 1, 2, 3. That gives us our new coordinates, and we can graph our function. Finally, we have C, which is negative f of x plus 1 minus 1. This is going to reflect the x-axis. Go left 1 and down 1. We have to start with this reflection. We need to do this first, and then we'll move our graph left 1 and down 1. So every point is going to reflect and go left 1, down 1. So if we start with this point, when we reflect it, right now it's 3 units above the x-axis. It'll reflect to 3 units below the x-axis, go left 1, down 1, which will put my point right there. Then we have our point below, which is 6 units below. It will reflect to 6 units above, go left 1, down 1, and that will be my next point. Then this point here reflects left 1, down 1. And finally, this point is 7 units above. It will reflect to 7 units below. Go left 1, down 1, and give us our last coordinate. So we can graph our function. Oops. There you go. Biggest point on these ones is when you have a reflection or a stretch or shrink, you need to do that first before you move it left, right, up, or down. Okay, last we've got our parent functions. So for these parent functions, we need to do, it gives us the name, we need to state the equation, the domain, the range, and the graph. So quadratic, our equation is y equals x squared. The graph is a parabola. Domain, because it goes all the way to the left and to the right, will be negative infinity to infinity in interval notation, or x is an element of all reals in inequality notation, okay, because it continues to the left and to the right. Exponential function, this is going to be y equals b to the x. When I actually graph it, or when we go to graph it, we need a number there, so most of the time we'll see it as y equals 2 to the x. So they mean the same thing. B is just for any number, 2 is a specific number, so we can actually graph something. It's going to travel real close to the x-axis and then shoot up. Our domain, oops, I realized I didn't do my range a second ago. We'll go back. Our domain here, the farthest left it goes is negative infinity. The farthest right it goes is positive infinity because it keeps on going. We write that as x is an element of all reals. The range of my exponential, the lowest it goes is 0, but it never actually touches that x-axis, so we're going to use a parenthesis. The highest it goes is infinity, or we can write this as 0 less than, because we don't actually touch the the x-axis, y. Let's go back up here to our quadratic so we can do the range. Range, the lowest our parabola goes is 0, and this actually includes 0. It touches the origin, so we're going to use a bracket to infinity. Or we can say 0 is less than or equal to, because again, we equal 0 at this point, y. So now we can move on to square root, which we call this radical. So keep in mind that square root and radical are the same name. Same thing for different name for the same function. There we go. Our equation is y equals the square root of x. Our graph starts at the origin and goes out. Domain, because it starts there at 0, 0, is 0 with a bracket to infinity. Farthest left is 0, farthest right is infinity, or 0 less than or equal to x. Our range is going to be the same thing because going low to high, it starts at 0, includes it, and keeps continuing up to infinity. Rational is our y equals 1 over x. The graph is in 2 parts, and it never touches either axis. So our domain, we're going to say negative infinity to 0 with a parenthesis, because we don't touch 0, union 0 to infinity, because we never touch 0, but we go everywhere else. The short version of doing it here would be to say x does not equal 0. Our range is the same thing, negative infinity to 0, union 0 to infinity, or y is not equal to 0. And finally, we have something, absolute value, which is y equals the absolute value of x. Our graph is a v, which we should be very familiar with now. Domain is negative infinity to infinity, or x is an element of all reals because it goes all the way left to all the way right. Our range, the lowest it goes is 0 and it touches it, so we get a bracket to infinity, maybe, or 0 less than or equal to y. So there you have the rest of your review. You've got all of your parent functions, your transformations, absolute value. Make sure you go through and do these a couple times until you feel really comfortable with the problems, and you're not having to look at your notes or look up any other information. Good luck.